sir.
Ah, what is the last topic? Previous topic ఏంటండి?
Conservative.
Applications of line integral.
Applications of line integrals.
Applications of line integral. Okay. So ఏమైనా డౌట్స్ ఉన్నాయండి అప్లికేషన్స్ ఆఫ్ లైన్ ఇంటిగ్రల్లో? No more? Okay. So before going to start the next class, just I will give the brief revision. Now in the previous class we have seen the applications of the line integral. The first application is if suppose F force field and the vector is F is equal to F1i plus F2j plus F3k, then total work done by F as particle moves from A to B along the curve C is integral A to B F dot dr. Okay, so this is the first application, and the second one is the if F is denoted velocity of the fluid, the integral F dot dr called as the circulation of F around closed curve C. So closed curve C, here C is missing, so closed curve C. Next one, third one. So I think this one is already over in the previous classes. The scalar potential field. So what is the definition of the scalar potential field? Given a vector point function f, there exists a scalar point function pi such that here the f is equal to gradient of pi, grade pi, or f is equal to del pi. So here this pi is called as scalar potential of vector point function p. And here we have the properties. What is the properties here? So we know that f is the here the function. The function is the vector point function. Now if f is equal to f1i plus f2j plus f3k and f is equal to suppose gradient of pi, definitely this f must be the irrotational vector, or the curl f must be 0, and this statement is if and only if condition. So if and only if condition means the converse of the statement is if f is irrotational vector or curl f 0 or del cross 0, then definitely there exists a scalar point function such that f is equal gradient pi, and here the f is pi is called as scalar potential of f. So that is the second property. And third property is, assume f1 is f is equal to f1i plus f2j plus f3k and f is equal to gradient of pi, and the pi is scalar potential of f. Then this f1 dx plus f2 dy plus f3 dz is equal to 0. It must be the exact differential equation. Exact differential equation means definitely the differential equation will write some derivative of some function. That is function is here the pi is the function. That means this differential equation will write d pi only. And one more, so it is the exact differential equation. The necessary and sufficient condition of this exact differential equation is dou f1 by dou y is equal to dou f2 by dou x, and the second one is dou f1 by dou z is equal to dou f3 by dou x, and third one is the dou f2 by dou z is equal to dou f3 by dou y. This is the necessary and sufficient condition of the exact differential equation. Okay, so this is the third property. Now the fourth one is the if the line integral path is suppose independent path, definitely there exists a f, then the f is equal to gradient of pi, definitely. Okay, that is the statement. And the fifth one is the if f is equal to f1i plus f2j plus f3k and the f is equal suppose the gradient of pi and the pi is the scalar potential field, that means scalar potential field means definitely we will write the d pi is equal to f1 dx plus f2 dy plus f3 dz. Okay, and in that situation the line integral of f is directly we will write the total result is pi only, because already this is the exact differential equation. That means this total differential equation we can write d pi only, sorry, d pi only. So d pi only, d pi means after integrating we get the pi result. Okay, so this is our fifth point. So or we can write if f integral f1 dx plus f2 dy plus f3 dz is independent path C if and only if f1 dx plus f2 dy plus f3 dz is equal to 0 is exact differential equation. Okay, so these are the properties. Okay. Next one more definition, conservative vector field. So what is the conservative vector field? So if the path, suppose independent path, then that type of function is called as, or field is called as conservative vector field. That means the definition is a vector field f is said to be the conservative vector field if its integral does not depends on the particular, only depends on the endpoints. Okay, and in this one necessary and sufficient conditions, the first one is f is suppose conservative field, definitely curl x must be 0 or del graph must be 0, or f is an irrotational vector, that is okay. And one more statement here, if f is conservative field, so already we know that it is the irrotation vector, but according to the scalar potential field, definitely if it is the irrotation vector, definitely there is a scalar potential field. That means there is a pi such that f is equal to gradient of pi. That pi we call as scalar potential of this f. Okay, this is the one more. I think we have seen in the previous class two problems. What is the first problem? So show that the given vector field is conservative field. That means we have to prove that curl x must be 0, or we have to prove that this vector is the irrotation vector. And the second condition, okay, second question is, and find its scalar potential field. So already it is the irrotation vector. So irrotation vector means definitely there exists a pi such that the vector point function we can write gradient of pi only. That, so we have to find the pi. That is the second question. And third question, and also work done moving the particle from the point 1 to point. Okay, so this is the first question. I think we did in the previous class. So the first one is here, just we have to prove that first of all conservative field. So the curl of this f must be 0, or del cross f must be 0. So already we proved. So del cross of this f is 0. So this given field is the conservative field. That is the first sub question. And second sub question is we have to find the scalar potential field. So scalar potential field means already it is the irrotational vector. Definitely according to this statement, d pi is equal to dou pi by dou x dx plus dou pi by dou y dy plus dou pi by dou z. So d pi by dx already we can easily find from the given vector, and dou pi by dou y also we can easily find the from the vector, and dou pi by dou z also we will find the from the vector. Substitute. Now this is the exact differential equation. Already we know that according to the properties. So this d pi is directly derivative of x square y plus this x square y plus x z cube. That means our pi is x square y plus x z cube plus c is the scalar potential of this f. This is the second sub question. And what is the third sub question? Also the work done in moving the particle from the point 1 minus to 1 to 3 comma 4. So 3 comma 1 comma 4. So that is the third sub question. That means we have to find the line integral. That means work done by force is integral f dr. Already what is the vector point function? This is the vector point function. The vector point function is vector point function 2xy plus z cube I plus x square j plus 3z square x k is the vector point function, and substitute. So this line integral we have to solve, but no need to solve directly because already this f is the irrotational vector. this f is the irrotation vector, that means this vector we can write d pi is equal to f1 dx plus f2 dy plus f3 dz. Okay, so already we know the result. Now the pi is equal to here, pi is equal to, according to the result, x square y plus x z cube plus constant. That means this total we can write derivative of x square y plus x z cube. Now the integration of this one is x square y plus x z cube, and the point 1 minus 2 I 2 3 1 4. Substitute x values are 1 3 and y values are minus 2 1 and z values are 1 4. Upper limit and lower limit. Now we'll get the result. 292 is the result. Okay, this is the first question. Now come to the second question also same. Here also we have the three sub questions. The first one we have to prove that the given vector field is the conservative field. That means you have to prove that curl of this f must be 0 or del cross f must be 0. Either del cross must be 0. So del cross must be 0. So this given vector is the conservative vector field. Second question is the, and also find the scalar potential of this one, and the third one is the third sub question, find the line integral from the path 1 comma 2 to 3 comma 4. Okay, now second sub question. What is the second sub question here? Now assume pi is the scalar potential. Why we are assuming this it is the scalar potential? Because already the given vector field is the irrotational vector. So that's why here there exists a pi such that f is equal to grade pi or gradient of pi or del pi. Okay, and we know that according to the previous one, f1 dx plus f2 dy plus f3 dz must be the exact differential equation. So definitely d pi is equal to f1 dx plus f2 dy plus f3 dz is equal to d pi. Okay, and what is the f1? This is the f1 and this is the f2 and f3 is 0. Substitute. Already we know that this is an exact differential equation according to the inspection method, just to find the our pi. So here the pi is equal to xy square by 2 plus xy cube plus c is the pi. But what is our third sub question? We have to find the line integral. Line integral f dr. So f dr means this is the our line integral. But luckily, so this is the now exact differential equation. Already we did. This is the exact differential equation. The total differential equation we will write the derivative of some pi, that means xy square by 2 plus xy cube plus c. Now substitute. Now the limits are 1 comma 2 to 3 comma 4. So upper limit is 3 comma 4 and lower limit is 1 comma 2. Substitute, we'll get the result 254 is the our result. Okay, I think this is the previous class revision. Okay, even homework ichana CS. CRs ఏమైనా హోంవర్క్ ఇచ్చానా? మై గాడ్, ఇచ్చానా ఇవ్వలేదు? హలో
సార్, ఒక క్వశ్చన్ ఇచ్చారు సార్, లైన్ ఇంటిగ్రల్ ఫైండ్ చేయమని.
సాల్వ్ చేస్తారా మరి? ఆన్సర్ ఏమొచ్చింది?
చేయలేదు సార్.
ఎందుకు? ఇంటర్నెట్ పని చేయలేదు? ఇప్పుడు చేద్దాం మరి?
చేద్దాం సార్.
ఓకే, ఏంటి ఆ క్వశ్చన్ ఒకసారి చెప్పు సిఆర్.
lambda xy minus z cube into I plus lambda minus 2 x square j plus 1 minus lambda x z cube k.
ఓకే, ఎస్, అదే కదా. ఓకే, క్వశ్చన్ రాస్తాను. ఫైండ్, ఫస్ట్ క్వశ్చన్ ఏంటి? ఫైండ్ ది కాంపోనెంట్ ఆఫ్ లాంబ్డానా? సిఆర్ ఒక సింబల్ చెప్పు. ఓకే, డాలర్. బాగుంది, డాలర్ అయిపోయింది. సిఆర్ ఆల్రెడీ చెప్పారు. ఓకే, సో డాలర్, సో దట్ suppose now f is conservative.
సార్, యూట్యూబ్ లింక్ షేర్ చేయండి సార్.
షేర్ చేయలేదా?
చేయలేదు సార్.
అదేంటి? మీరు అడగట్లేదేమో. అచ్చా, గుడ్. లిమిట్ 99కి వెళ్ళిపోయిందా? ఓకే, బాగుంది. ఓకే ఓకే. సో కన్జర్వేటివ్ మళ్ళీ మీకు ఏమైనా క్లాస్ ఉందా అండి ఇప్పుడు? ఫిజిక్స్ క్లాసు, కెమిస్ట్రీ క్లాసు, ఇంగ్లీష్ క్లాస్ ఏం లేవా? ఓకే. సో కన్జర్వేటివ్ vector field. So this is the first question, and where here our vector f is $xy minus z cube I plus minus 2 x square j plus 1 minus $3 z square k. So first of all we have to find the lambda. How can you find the lambdas here? What is the idea? So the given vector is, it is clearly given conservative vector field. Conservative vector field means, what about that internally? What is the necessary and sufficient condition for this conservative of vector field? Necessary and sufficient. It must be the del cross f must be 0, or curl of this f must be 0, or this f must be the irrotational vector. Okay, so from this one just we have to find the our dollar. Now we'll find the, now first row is ijk. I am writing directly. Direct right chandi.
రాయండి సార్.
Okay. So second row is dou by dou x, dou by dou y, dou by dou z, and what is the third row? $xy minus z cube and minus 2 into x square and 1 minus $3z square is equal to 0. Now find the determinant of the matrix. What is the determinant of the matrix? Now I into the first result is, it is without y, so 0, minus it is without z, this is also 0, minus j into it is without x, so 0, and it is with z, so minus 3z square plus k into, after differentiating with respect to x, to minus 2 into x, after differentiating with respect to y, minus $x is equal to 0. Correct andi? And miss అయ్యా? ఏమైనా మిస్ అయ్యాయండి? క్వశ్చన్ కరెక్టే అండి యాక్చువల్గా?
క్వశ్చన్ రాంగ్ సార్.
క్వశ్చన్ ఓకే ఓకే. ఎక్కడ మిస్ అయిందండి? 3
అక్కడ 3 కాదు సార్, xz2.
క్వశ్చన్లో xz2. ఓకే సారీ మిస్, xz2 కే అంతేనా? ఓకే. సో సారీ మిస్సింగ్. xz2 క్వశ్చన్ మొత్తం మార్చాను. ఓ మై గాడ్. సో xz2 okay. Now the first one is, oh my god, this is also 0. First one 0, second one will change. So minus j into 1 minus $z square minus of minus 3z square plus k into 2 dollar minus 2 into x minus dollar x is equal 0. After simplification, what we'll get here? I into 0 minus j. In this one, we can write 1 minus dollar into z square plus 3z square plus k into 2 dollar x minus 4x minus dollar x is equal to 0. So I into 0 minus j into 4 minus dollar z square plus k into dollar minus 4 into x is equal to 0. After comparison, we will get that the 4 minus dollar is equal to 0. After comparison, now the dollar is equal to 4. Okay, if the dollar is equal to 4, this the given vector field is the conservative vector field, or the given vector is the irrotation vector. Now irrotation vector means, what about that mean? Definitely there exists a scalar potential field. Okay, that is our second question. Our second question is, this is the second sub question is, and find its scalar potential field. Okay, that is the second question, and it is clearly, we know that what is the second question, second one. So already is clearly know that f is the conservative vector field. That means, what about that means? Now f is must be the irrotational vector. According to the statement, definitely there exists a pi such that, now we are assuming, let us assume pi is a scalar potential field, and f is equal to gradient of pi. And according to the previous statement, what is the statement? D pi must be is equal to f1 dx plus f2 dy plus f3 dz. But what is our f? What is our given f? F is equal to, what is the statement? Dollar x y minus z cube into I plus dollar minus 2 into x square j plus 1 minus dollar x z square into k. Now just substitute dollar is equal to 4. After substituting dollar is equal to 4, what is our vector field? 4xy minus z cube into I plus 2x square j minus 3x z square into k. In this one, this is the our f1 and this is the our f2 and it is our f3. Now substitute. After substituting this f1, f2, f3, now it became 4xy minus z cube into dx plus 2x square into dy minus 3x z square into dz. And according to the previous statements, this differential equation must be the exact differential equation. By using the inspection method, just to try to write. Now here, so here, now just combine. What is the combination here? Oh, sorry. Just here this is the x and y combination, so we have to join these two. And this is the x and z combination, you have to join these two. So come to the first part. First part we will get the 4xy into dx plus 2x square dy. So 2x square dy, that means here write y into d derivative of 2x square, we can write plus 2x square dy. Now it is the a into derivative of b plus b into derivative of a. This total we can write derivative of 2x square y. That means these two results after combining we'll get the 2x square y is the result. Next one, come to the second part. Now here we'll get the minus is common, then z cube dx plus 3xz square into dz. So already here z cube dx. So here we have to create x into derivative of z cube. We can easily create. Because here there is a 3 and there is a z cube square dz. We can create. So plus x into derivative of z cube. By using the product rule, we can write derivative of x z cube and it is equal to d pi. That means according to the additive rule or subtraction rule, we will write d pi is equal to derivative of 2x square y minus x z cube. After integrating, we will get the pi is equal to 2x square y minus x z cube plus c is the result. It is the scalar potential of f. Okay. So it is the second sub question. What is the third sub question? Third sub question is just to find the third sub question. Third one is just to find the line integral f dr, and where c is path from 1 to minus 3 to 1 minus 4 and 7. And same question they will give like this also, that is, and also find work done in moving the particle from the point 1 comma 2 comma minus 1 to 1 comma minus 4 comma 7. Okay, same question. Directly they will give the what is the line integral of the f dr, or the question may be like this. That means just you have to find the only line integral. Now come to the third sub question. Now the question is the line integral. Now integral f dr. The curve is from the point 1 comma 2 comma minus 3 to 1 comma minus 4 comma 7, or what is the second 1 minute. Now the second way to write. So find work done in moving particle from the point 1 comma 2 comma minus 3 to 1 comma minus 4 comma just a minute only. 2. Okay, and luckily we have here what is our integration here? The integration f, what is our f vector? F, see here f em ochindi, f is equal to గుర్తుందా, నోట్ చేశారా? 4xy minus z cube into I plus 2x square j minus 3xz square in z. So line integral means after rewriting what will get the line integral. Now integral or work done by force F is equal F dot dr on the curve, or integral 4xy minus z cube into dx plus 2x square dy minus 3xz square into dz along the curve C. But according to the previous one, what we are getting here, d pi is equal, what is the d pi value? f1 dx plus f2 dy plus f3 dz. Assume it is f1 and f2 f3. Already we know that this differential equation 4xy minus z cube into dx plus 2x square dy minus 3xz square dz. What will get the result? Derivative of 2x square y minus xz cube is the result. That means here the conclusion is no need to integrate. Directly already this total part we are writing the derivative of 2x square y minus xz cube only. Okay, and what are the points from 1 comma 1 comma 2 comma minus 3 to 1 comma minus 4 comma 2. So after integrating we get the 2x square y minus xz cube, limits from 1 comma 2 comma minus 3 to 1 comma minus 4 comma 2. Upper limit is 1 comma minus 4 comma 2 and lower limit is 1 comma 2 comma 3. So after substituting upper limit, 2 into 1 square minus 4 minus 1 into 2 z cube minus lower limit is 1 to minus 3, that means 2 into 1 into minus 2 into 1 into 2, 2 into 1 square into 2 minus 1 into minus 3 whole cube. So the result is here minus 8, here minus 8, minus it is 2, 4, minus or minus plus it is 27. So final result here, so minus 16, minus 31, the result is minus 47 is the result. Okay, so the line integral of this one is the minus 47 is the result. Okay, ఇంకేమైనా ఇచ్చాను here homework problems?
నో సార్ ఇది ఒక్కటే ఇచ్చారు, కానీ అవి కర్వ్ వాల్యూస్ ఇవ్వలేదు సార్, అందుకే చేయలేదు.
అచ్చా, ఓకే. మిగతా ఏమి ఇచ్చాను? ఇంకా క్వశ్చన్స్ ఇచ్చానా?
నో సార్.
లైన్ ఇంటిగ్రల్ మీ ఇవ్వలేదు.
ఇచ్చారు సార్ నిన్న హోంవర్క్.
ఓకే, ఇంకా ఇవ్వాలా మీకు? ఓకే,
ఇవ్వండి సార్.
ఇస్తా. సో ట్రై టు సాల్వ్. ఆల్రెడీ ఇచ్చినట్టున్నాను, ఇవ్వలేదు. ఓకే, సో ఆ క్వశ్చన్స్ సాల్వ్ చేయండి బెటర్. ఓకే, so now this one is the about the previous class review.